Imagine being told that the only way to run old Windows applications is to keep using Windows itself, install a virtual machine, or set up a complicated dual boot system. For years, that was considered the standard advice. But in 2026, that assumption is becoming increasingly outdated. What if I told you that some legacy Windows applications can actually run faster on Linux than they do on modern versions of Windows? And all of this is possible without virtualization, without emulation in the traditional sense, and without rebooting into another operating system. It sounds unbelievable, but thanks to advances in native Linux compatibility tools, this is becoming a reality for thousands of users around the world. Today we're exploring one of the most surprising developments in desktop computing, running legacy Windows software faster than Windows 12 itself, using native Linux tools. No virtual machines, no dual boot. Just Linux and a carefully optimized compatibility layer that can make old software feel brand new again. To understand why this works, we first need to look at what has happened to Windows over the years. Modern Windows has evolved into a massive operating system with countless background services, telemetry systems, security layers, AI features, cloud integrations, and resource-intensive components. While many of these additions provide useful functionality, they also create overhead. Older applications that were originally designed for Windows XP, Windows 7, or even Windows 98 often end up competing with a much heavier operating environment. Linux, on the other hand, can be incredibly lightweight. A modern Linux desktop can boot using a fraction of the resources consumed by Windows 12. Memory usage is often lower. Background activity is reduced, and users have complete control over what runs on their systems. This creates an ideal environment for running older software that doesn't need all the extra complexity of a modern operating system. The key technology making this possible is Wine. Despite its name, Wine is not an emulator. In fact, Wine stands for Wine is not an emulator. Instead of simulating hardware or creating an entire virtual Windows environment, Wine translates Windows API calls directly into native Linux system calls. This approach eliminates many of the performance penalties associated with traditional virtualization. Think about what happens in a virtual machine. Your computer runs Linux or Windows as the host operating system, then launches a second operating system inside a virtual environment. Every instruction must pass through multiple layers before reaching the hardware. This inevitably introduces overhead. Even with modern virtualization technology, there is still a performance cost. Wine takes a completely different approach. When a Windows application requests access to memory, graphics functions, file operations, or networking services, Wine translates those requests directly into Linux equivalents. The application essentially runs alongside native Linux software instead of inside a separate operating system. Because there is no full Windows installation consuming resources in the background, performance can often be surprisingly good. Over the last few years, Wine has improved dramatically. What was once considered a hobbyist project capable of running only a handful of applications has evolved into an incredibly sophisticated compatibility layer. Thousands of Windows applications now function with little or no modification. Popular productivity software, business applications, legacy engineering tools, educational programs, and even many games work remarkably well. One of the biggest breakthroughs came from the gaming world. Valve's Proton project, which is built on top of Wine, pushed Linux compatibility to new levels. Although Proton was originally created for gaming, many of its performance improvements benefit Windows applications as well. Graphics translation technologies like DXVK and VKD3D convert Microsoft's DirectX instructions into Vulkan commands, allowing software to leverage modern Linux graphics drivers efficiently. This has led to some fascinating benchmarks. Users have reported older DirectX applications launching faster under Linux than on Windows 12. In certain scenarios, frame rates are higher, loading times are shorter, and system responsiveness improves noticeably. While results vary depending on the software, the trend has become difficult to ignore. Another reason legacy applications can perform better on Linux involves storage access. Modern Linux file systems are highly optimized and efficient. Combined with lower background disk activity, older applications often experience faster startup times. Many users notice that programs which take 10 or 15 seconds to launch on Windows can open almost instantly under Linux. Memory management also plays a significant role. Linux has long been praised for its efficient handling of system resources. Older Windows applications were often designed during an era when computers had much less RAM available. When those same applications run in a streamlined Linux environment, they frequently benefit from reduced competition for memory resources. Security is another unexpected advantage. Running old Windows applications on modern Windows versions can sometimes create compatibility problems because of newer security restrictions. Certain legacy software expects behaviors that no longer exist in current Windows releases. Linux compatibility layers often provide a cleaner bridge between old software and modern hardware, allowing applications to function without constantly fighting operating system changes. Many Linux distributions now make this process incredibly simple. Tools like Bottles, Lutris, and Heroic have transformed Wine configuration from a technical challenge into a mostly graphical experience. Instead of manually editing configuration files and installing libraries one by one, users can create isolated application environments with just a few clicks. Bottles, in particular, has become a favorite among Linux enthusiasts. It allows users to create separate containers for different applications, each with its own settings, libraries, and optimizations. If one application requires a specific Windows version or runtime component, it can be configured independently without affecting anything else. This level of flexibility often exceeds what is possible on Windows itself. Consider a real-world example. Imagine a business that relies on a 15-year-old accounting application designed for Windows XP. Running that software directly on Windows 12 might involve compatibility mode adjustments, administrator privileges, registry tweaks, and occasional instability. Under Linux, the same application can often run inside a dedicated Wine environment configured specifically for its requirements. Once set up, it may perform faster and more reliably than on Microsoft's latest operating system. The same pattern appears in creative software, educational programs, industrial control tools, and older productivity suites. Many applications that companies considered obsolete are finding new life through Linux compatibility technology. Of course, this doesn't mean every Windows application runs perfectly. Compatibility remains software dependent. Some applications rely on kernel-level drivers, anti-cheat systems, proprietary frameworks, or undocumented Windows behaviors that Wine cannot fully replicate. There are still edge cases where native Windows remains necessary. However, the compatibility gap continues to shrink every year. Development communities around Wine and Proton are constantly identifying issues, implementing fixes, and improving performance. What failed to run 6 months ago may work flawlessly today after an update. Hardware support also contributes to the experience. Linux graphics drivers have matured significantly, especially for modern AMD and Intel hardware. Vulkan support is now excellent across much of the ecosystem. As a result, graphics-intensive Windows applications often benefit from efficient translation layers and optimized rendering pipelines. Power users frequently go even further by customizing their Linux systems specifically for compatibility performance. They disable unnecessary background services, optimize CPU scheduling, fine-tune memory settings, and use lightweight desktop environments. The result is an operating environment dedicated almost entirely to running applications, rather than supporting operating system overhead. This trend highlights a larger shift occurring throughout the computing industry. Increasing numbers of users are realizing that operating systems should serve applications, not the other way around. If a lightweight Linux environment can run legacy Windows software more efficiently than Windows itself, it challenges long-held assumptions about platform dependency. There is also a financial dimension to consider. Organizations with large collections of legacy software often face difficult decisions when upgrading hardware or operating systems. Purchasing new software licenses, migrating workflows, or maintaining outdated Windows installations can become expensive. Linux compatibility tools provide an alternative path that allows businesses to continue using existing software while benefiting from modern hardware and security updates. For enthusiasts, the appeal is equally strong. Many people have favorite applications from previous decades that no longer function properly on modern Windows versions. Linux provides a way to preserve access to these tools without maintaining aging systems or hunting for discontinued operating system licenses. What makes this especially remarkable is that none of it requires dual booting. Users can enjoy a complete Linux desktop experience while launching Windows applications whenever needed. Email, web browsing, programming, media consumption, and productivity tasks all happen within Linux. legacy Windows applications simply become another part of the workflow. The idea that Linux is only for programmers or server administrators is rapidly disappearing. Modern desktop distributions offer polished interfaces, automatic hardware detection, extensive software repositories, and user-friendly configuration tools. Running Windows applications has become just another feature rather than an advanced technical challenge. As Windows continues growing more complex and Linux compatibility technologies continue improving, we may see an increasing number of scenarios where Linux becomes the preferred platform for running older Windows software. That statement would have sounded absurd a decade ago. Yet today, it is backed by countless real-world examples and performance tests. The most surprising part is that this isn't about abandoning Windows applications. It's about giving them a new environment where they can thrive. Through Wine, Proton, DXVK, Bottles, and other native Linux tools, users are discovering that legacy software doesn't have to be trapped in the past. It can run efficiently on modern hardware, take advantage of optimized Linux systems, and in some cases even outperform its experience on Windows 12. The future of compatibility is no longer about emulation, virtualization, or maintaining multiple operating systems. Instead, it's about intelligent translation layers that connect software to hardware as efficiently as possible. And if current trends continue, Linux may become one of the best places to run the Windows applications of yesterday, not despite being a different operating system, but because it has evolved into a faster, leaner, and more efficient platform for doing exactly that.